A machine randomly generated one of 9 numbers, 1, 2, 3 through 9, with equal likelihood. What is the probability that when Tsuni uses this machine to generate 4 numbers, their product is divisible by 14? Express your answer as a common fraction. So since all numbers are generated with equal likelihood, probability to have 4 numbers such that their product is divisible by 14 is simply equal to number of cases where product of 4 numbers is divisible by 14 divided by total number of cases. So first we start with calculating total number of cases. So effectively we have 4 numbers, so 4 slots. First we're going to fill the first slot. We can fill it with a number from 1 till 9. So there are 9 ways to fill that slot. Next thing we're going to do, we're going to fill the second slot. Again, there are 9 ways to fill the second slot. But there are 9 ways to fill the second slot for each of the 9 ways to fill the first slot. So the total number of cases you're going to have to fill both slots is 9 times 9, or 81. Now let's continue to add a third number. Again, there are 9 ways to get this number, but those 9 ways are for each of 9 times 9 ways to fill the first 2 slots. So the total number of possibilities with 3 numbers is 9 times 9 times 9. Similarly, when we fill a 4th spot, we multiply number of possibilities by 9 again. So the total number of possibilities is 9 to the 4th power. Let's look now at the numerator right here. Number of cases where the product of 4 numbers is divisible by 14. So what does it mean that the product of 4 numbers is divisible by 14? Well, it really means that if I have 2 numbers, A, B, C, and D, and this product is divisible by 14, that means that this product can be represented as 14 times some integer k. Well, 14 is 7 times 2, so we can write it 7 times 2 times k. But now, what does it mean that A times B times C times D equals 7 times 2 times k? What it means that at least one of those 4 numbers, A, B, C, or D, should have a factor of 7, should be divisible by 7. And at least one of the numbers, A, B, C, and D, or D, has to have a factor of 2 in them, which means at least one of those numbers should be even. Okay? Now, remember those numbers A, B, C, and D are not just random integers. They are integers between 1 and 9. Okay? Which means that if you want to have a number that between 1 and 9 that's divisible by 7, it really means that the number has to be 7. If you want a number to be divisible by 2, there are 4 options. It could be number 2, 4, 6, or 8. Okay? So what we got so far, the numbers, if we're looking for 4 numbers that have their product divisible by 14, it means that out of these 4 numbers, at least one has to be 7. And at least one number should be an even number. Obviously, they cannot be 7 and even number at the same time, right? All right, let's do counting now. First, we're going to count only the cases when we have just 1 7 and 1 even number. Okay? So we have 4 positions for 4 numbers. And first, we want to put a 7 somewhere. There are 4 positions, so we can put 7 in 4 ways. Okay? After we put 7, and there are 4 ways to put 7, we have 3 positions left. So what we're going to do next, we're going to put an even number in one of those 3 positions. Since there are 3 positions left, there are 3 ways to put that even number. Okay? And total number of positions possible is 4 times 3, 12 positions. But now we need to remember that when we say even, we mean actually 4 possibilities. So when I say there is a case of 7 and even, I'm essentially saying there are 4 cases of 7 and even. So there are not total 12 cases, there are total 12 times 4 cases to put 1 7 and 1 even number. But once we put those 7 and even numbers, now we have 2 spots left, here and here. And those spots have to be occupied by numbers other than even and 7, which means that there's going to be an odd number that is not 7. And we have 4 of those, 1, 3, 5, and 9. So there are 4 ways to fill the first slot, and there are 4 ways to fill the second slot. So in this case, total number of cases we have when we have just 1 7 and 1 even number is 3 times 4 to the 4th power. So the second thing we're going to consider is when we have 1 7 and 2 even numbers. Okay? Again, our 4 positions. We put 7 somewhere, and there are 4 ways to do it. And then we want to put 2 even balls into the remaining 3 places. So essentially we're saying, we're asking a question, how many ways can I position 2 even balls into 3 spots? And the answer is there are only 3 ways to do it. Okay? But now we need to remember that one even ball is 4 possibilities. There are 4 even numbers. So we need to multiply number 12 we have by 4, representing this first ball, and also multiply by 4 that represent the second ball. Okay? So total number to fill 3 spots, 1 with 7 and 2 with even balls, is 4 times 3 times 4 times 4. And now we have 1 spot left, and that needs to be filled by odd number that is not 7. And there are 4 choices there. So the total number of possibilities when we have 1 7 and 2 even balls, or 2 even numbers, is 3 times 4 to the 4th power. Now let's consider the third case, when I have 1 7 and 3 even balls, right? Or 3 even numbers. 4 spots. We put a 7 ball. There are 4 ways to do it. And then I just fill the rest of the spots with even balls. And the next thing we need to remember that each even ball is actually 4 different numbers. So we need to multiply these 4 possibilities for 7 ball by 4 possibilities for the first even ball, 4 possibilities for the second even ball, and 4 possibilities for the third even ball. So, and total number of cases in this case will be 4 to the power of 4. So the next case is when we have 2 7 balls and 1 even ball. 4 spots. Now we want to put 2 7 balls into 4 spots. Number of combinations for putting 2 identical balls into 4 slots is 6. Okay. Once we put those 2 7 balls, there are 2 positions left. So there are 2 ways to put an even ball. Now, even ball is actually 4 different situations. So really, we have to get the whole number of possibilities with 2 7s and even balls as 6 times 2 times 4. And now we have one extra spot left, and that spot is occupied by odd number that is not 7. There are 4 possibilities. So we have to multiply what we have by 4. And that is the final answer, which is 12 times 4 to the second power. The next possibility we have is 2 7 balls and 2 even balls. We have 4 slots. We put 2 7 balls. There are 6 ways to do this. And the other 2 spots are going to be filled by even balls. Each even ball is 4 numbers. So the 6th number needs to be multiplied by 4 to account for 1 even ball, and multiply by 4 again to account for the 2nd even ball. Total 6 times 4 squared. Now, this is a situation when we have 3 7 balls and 1 even ball. We have 4 spots. We're filling 3 out of 4 by 7 ball. There are 4 ways to do that. And now the last spot is filled by even ball, which means 4 different possibilities. So a total number of possibilities, in this case, 4 squared. So, and that's going to be it. So there's no other possibilities to have at least 1 7 ball and at least 1 even ball. So all we need to do now is to add all these numbers, and that can be done quite easily. And the final answer is the number of cases divisible by 14 is 2096. Now remember that probability we are interested in is number of cases where the product of 4 numbers divisible by 14, which is 2096, divided by total number of cases, which is 9 to the power of 4. So final answer is 2096 divided by 6561.